Hello everybody. Hope you guys are doing well. So we will be continuing on with our journey in Swift, and today we would be talking about property wrappers because I feel now it is the correct time for us to know what property wrappers are and what's the use of what's the advantage of wrapping a property, and then we will also see like what property are what do we mean by wrapping a property, like what what are we wrapping it around actually. Okay, so then let's see now. What is a property wrapper? A property wrapper, as the name suggests, is a powerful Swift feature that wraps properties with custom logic influencing the behavior. Whether we are creating our own custom property wrappers or harnessing the capabilities of the ones provided by Apple's framework. Property wrappers play a very important role in enhancing code modularity and maintainability. Now, in SwiftUI and Combine, for example, property wrappers are highly central to state management. We will see that soon. Property wrappers are basically recognized by their annotation using at the rate symbol before the wrapper name. Okay. In for example, let's see an let's see a custom property wrapper that is called as at the rate capitalized. Now, at the rate capitalized hasn't been implemented. So the way to write a property wrapper is basically, oh, let's get rid of this. Is basic the way to write a property wrapper is basically by adding the at the rate symbol. Now, what does the wrappers do? It kind of adds additional features or attributes or to the property. Okay. Now, uh, okay. For example, at the rate capital I. For one example, could be at the rate state, and then this is my property, right? So my property is my. So remember, these are so whenever we declare anything inside a struct, right? For example, a variable inside a struct is called as property. So what we are doing is this. So that variable inside the struct, we are kind of adding some additional features. Okay. And we can automatically. What's the advantage of using? So what happens is there is some custom. So instead of like redefining that property, what we can do is we can already use the already defined logic and then just apply to that property, saying that from now on that property will also follow that behavior. So it kind of helps in writing less code, and also it's help in modularity. By the thing is, you can add the same wrappers to different properties. Now, how does they work under the hood? Um, okay. Mm, okay, so for example, let's see one property wrapper, and then we will see how it is defined under the hood. So this is No, that's not that. Okay. Uh, oh no, let's get rid of it. This is not the struct, right? The struct is yeah. So okay, so now this is you have this is how this state wrapper is defined. Okay, so first thing, let's see how it's working in real life. Now, property wrapper will always start with at the rate property wrapper attribute. Now, in Swift, attributes in Swift provide additional essential information. We are likely to encounter different attributes. For example, IOB outlet, at the rate object, or at the rate available. These attributes give vital information to the compiler at the various stages of the processing. Now, in our case, at the rate property wrapper informs the compiler that this struct is a wrapper and should be treated as such. It also enables us to apply a custom property wrapper to our properties. It's in the wrapper. You'll find a stored property called as value, and this property actually holds the value of my property. Okay, so he's saying how he has defined it. Okay. Now there are four key points. First is every property wrapper. So it's usually this. So this is basically at the rate property wrapper. We are saying that this will allow you use the struct name as a property wrapper. So then, so what does so the struct name is state, right? We are using this property. Okay, let's break down this. Let's break it down. So when we okay, wait. Let's have a new window. Let's go to RTL draw. RTL draw. Uh, I need a new project. Wait, so let's go here. Okay, let's minimize. So let's try to understand how um property wrapper definition, how they are defined in the okay. Okay, so the first thing is we kind of mention at the rate property wrapper. Now what does this enables us to use the struct name as the wrapper name. For example, if you come in, see over here in this, okay, let's so you see in this struct, uh, where is the other row? This is the other row. What's open? I don't know where it is. Or let's minimize and then get rid of. For example, if you want to see this, uh, for example, so we see this thing at the rate this no. For example, let's have this wrapper in. I don't know what has happened. So if you see this properly, um, this is the struct name, right? So when we define the state property wrapper, we would be using at the rate state, which is the name of the struct because of this property wrapper that is already mentioned there. Okay. Now inside the property wrapper, there is a stored property called value. Okay. Now let's see the inside thing. Now inside this wrapper, I have a dynamic. Okay, this is conforming to dynamic. So this, yeah, I have this inside. Inside the wrapper, there is a stored property called value, which is this, and then this is the init for the struct, right? Which holds the actual value of the property wrapper per attribute annotates. Additionally, then we will have contains a computed property. So then we have something called as wrapped. So this is a computed, right? Because we are doing getters and setters. So this is basically where the logic for the property wrapper is typically placed in. So if you see this way, there is a method in which you define property wrappers. Okay. So first, so let's see what are the steps to define property wrapper. Now, so if then let's see a case. So let's see case 1. Now what this case is, when we want to use the name of the struct as the property wrapper, what we do is we mention at the rate property wrapper at the rate property wrapper before the struct name. Okay, this is no, I need to expand, right? No, how to rotate? This is case number 1. Now then we have okay, so or you can say this is step 1. You can call this as step 1. Then so inside, what is the step 2 basically is inside the wrapper there will be a attribute called as value, which will store the value. Perfect. Then we have another, which is step 3. What does this do? Now in step 3, we okay we will have a computed uh, property which will uh, which will have the actual logical implementation. Okay, and this will be the name of the computed okay, the name of the computed property will be no, let's have this as green. Will be let's have a T, and then let's have something that will be wrapped value. So this is how all property wrappers are defined. This is a set method to do it. Okay. A Swift UI and value types. Now Apple has introduced a range of their own property wrappers for seamlessly integrating with the main advantage is because if we did not have the wrappers, right, then we would be wasting time in writing all the logic for those wrappers. So what what Swift has done is, instead of for us wasting the value, you can just use the already implemented logic. Okay, so now let's see. Now, while examining basic SwiftUI, you will see that these are exclusively compared or structs. Attempting to change the type class will result in a compile time error. This is due to the V protocol, which is the very foundation of how you have the UI. Okay. Um. Okay. Now, when examining a basic SwiftUI file, you'll quickly notice that there are exclusively composed or structs. Attempting to change the type will result in a compile time error. This is due to the V protocol. The foundation of SwiftUI is specifically designed to work with structs rather than with classes. To understand the rationale behind the design choice, we first need to examine the difference between the structs and classes. The core distinction lies in the structs are value types, whereas classes are reference types. And when we create an instance of a class and assign it to the another variable, both have the access to the same memory space. Whereas when we do abstract, what we do is we create another memory space and a copy is being passed. So then he's just showing it in uh, how classes are different, how structs are different from classes. Okay. So the one of the main thing is, whenever you have classes are reference types, right? Copies are not passed. However, what we do is we kind of use different references to refer to the same memory space. The structs are value types. So remember, whenever we are passing a struct, we are basically referring to value types, and what that means is, whenever we are doing pass by copy by value, and there is no pass by um, like whenever we try to pass it, we do a value passing. So whenever there is a value passing that happens, that basically means is um, uh, copy will be passed instead of the actual one going in. Now let's study some important uh, property wrappers. Now first is the at the rate state. And the okay, and transitioning to a new SwiftUI project. Now this is simple. Our goal is to okay for by the first now let's list down the advantages of using wrappers. What one of them is no need to that it causes, or I can say it avoids repetition of code. Repetition of code. Like using the wrapper, uh, like having the wrapper, we can add additional properties to the property variable without writing any extra logic. Let's have this. Let's hide this. It avoids repetition of code, and then we can add additional properties to the wrapper itself. Okay. Then again, so what does that lead to? We get a modular code. Items in modularity, and yeah, that. These are the main advantages of using a property wrapper. Now then there are certain wrappers inbuilt in Swift. So we are going to see in inbuilt um, wrappers. The first one that we are going to study is at the rate. Oh, this is green, right? Let's change the color. The first one that we are studying is at the rate straight. Okay, so now what this is going to do is remember. Let's step away from the playground and see. Let's go into Swift. So like, what if? Okay, let's have Xcode open. I hope it's visible, right? Let's minimize this. Okay, and let's get Xcode. Yeah. So let's go to content view and then see. So remember this at the right state where. Okay, let's without using this wrapper. So we then say this is this be a string, right? And then okay, let's assign it a string saying this is my. So remember this property is where, right? So we can. So then we do so yeah, remember that is a text, right? You can just have it on the screen. Oh, let's refresh it now. Now let's do a button. Okay, let this be label. Okay. Now whenever an action, I'm going to assign this variable, this property, to another thing. This is assigned to another variable. And then in code, let's have in label we are going to give it a text saying let this be button. Not assign properties self is immutable. Why? Immediately we'll see an error. Now cannot assign property self is immutable. Now in SwiftUI structs are fundamentally immutable, right? When you when you yet when the situation calls for modifying a property value, SwiftUI offers an approach that mirrors those process. Using the state upper next to the our property, we gain the ability to assign new values to our property. But in SwiftUI, do not directly mutate the property values as you would with classes. Instead, any changes to a property marked with the state result in the creation of a new struct of a new copy of the struct. In other words, when a state property, other state property is assigned a new value, the property does not change, but rather the entire struct is recreated as a copy along with the updated value. Now, the struct isn't created from scratch. However, a copy of the old struct is created, and SwiftUI determines the difference between the old and the new struct, and then applies the updates accordingly. Now, so what he's saying is, now we'll get something called as so we can say cannot assign property to self is immutable, right? So there is one big thing about structs, right? Why we get that immutable error is because why does not allow, because whenever you are passing it, right, now Swift does not know whether we are making changes in the original struct or it is a copy of that struct. There is no way to distinguish between that. So hence we get an error. But then what we can do is we can so what we do is we kind of use a wrapper around this. What we do is we have at the rate straight wrapper. Now what that does is, now that kind of takes care of this struct immutability without the need for us to worry about that. So yeah, so then what we'll do is whenever there is a change, right, what it does is it creates a new copy of it, and then it compares the uh, what the UI is. Remember, the Swift UI is based on a process called as diffing algorithm, right? That means a diffing tree is generated. So this is being generated in the first what do you say, in the first rendering, right? You have this string and then you have this button. Now whenever I try to change the behavior, right, now what inside Swift it does is it creates a copy of this struct, because Swift are always structs in Swift are always passed by value. So you cannot and so as they are passed by value, a copy will be passed. So then there is no way for Swift to decide whether I am referring to the original one that is written or whether that is the new copy that is being generated. So hence we are getting that Swift is, self is immutable kind of error. Now what does at the rate state do? State will solve this immutability problem. So what it does is it kind of creates a new copy with it kind of creates a new copy of this struct. Now since we have used the average state, so it knows where the changes have been occurred and whether it is the original struct or whether it is in the copy. So and then it compare, and then the diffing tree will compare, right? So the whole idea of using average state is because we cannot assign is because like the SwiftUI content in view is as a struct. So creating a copy of that struct will always get that immutability issue, whether we won't be able to decide whether we are on the original struct or whether we are on the copy. Hence that at the rate state kind of does that binding, and says, that this is the copy of the struct. This is not the original struct. So then now Swift knows, like, okay, this is a copy. So then what it will do, it will just now, here is when that diffing thing comes into existence. So it will check whether there is any difference between the original struct and the copy. Since it finds that there is a difference, so instead of re-rendering the entire struct, it will only re-render the 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 part of the struct which has changed. So that is something why we use state. So basically, uh, what we are trying to overcome in using at the rate state is that immutability property of structs. Yeah. So because yes, let's uh, let's add a note. Let's write something down. Okay. So first, let us write why did we use it. Like, um, uh, mm, let's get rid of this. Let's have a text, new one. Let's forget about that. That and we. What is the need? What is the need for at the rate state? Let's see. Okay, let's say solution, and then say by default struct uh, type values, and when we try to change anything inside struct, uh, we won't be able to do that because we will get an error saying, let's have this, uh, struct immutable. What happened? Why did the class struct? No, why are we talking about immutability? Uh, Swift UI follows the reconciliation process wherein wherein using the define algorithm, a new tree is generated. Now a new tree is generated, and when we generate, and as the content view is a struct, new copy will be generated, and we will not be able to understand whether we are working with the copy or with the original one. So that is, so then what does state do? So let's yeah. Then we say at the rate state false this immutability problem by creating a, a copy of the struct when the uh, property value property value changes. So SwiftUI already knows that this is a copy. Now comparing now the diffing algorithm say no diffing algorithm says instead of rendering the entire struct, just render the changes. Instead of re-rendering, the whole thing is about re-rendering, right? Just re-render the copy. Okay, this is what when we say is why is the need for the state wrapper. Okay. Now the two-way binding problem. Now there is some more issue with the state. Now remember, um, so why do we need to do that binding? Now there is okay. So now there is a problem. Now let's examine something. When we assign a new value to my property by clicking a button, we are directly modifying the state where. So for example, what I'm trying to do is so here now what I should do is just make this state and the error goes. So now whenever I click this button, if I try to print this thing on I say you print my property. I don't know whether it's coming here. Yeah, see, this is coming right. This changed. The text has right now changed. If you see when you click this button, as initially it was my property was saying like this is my string. Then the moment I click this, that value has changed. So what we are doing is we are directly modifying the state variable my property using the equal sign. That's working. Okay. I don't know why it kind of moves off the screen. Wait, let me have position a little bit. This is irritating. Wait, that's something. Let's go. Oh, this has turned on. I want this on. Why is this on? Yeah. This is the window that we want to be on. Okay. Now the two-way binding. That's what we were talking about. Okay. Yeah, so in that we have directly modified the state variable, right? Using the equal to sign. Now some UI components seamlessly integrate with and bind to the state variables. Let's illustrate this using a text field. The initially argument title key, so is saying a text field and then there is already some binding here. The any text entered in the text will be promptly be updated to my property along with the text displayed within the text field. The text field update. So some UI in default already some elements do that two-way binding. So right now it's only one way. That means whenever when we click the button on basis of that, that my variable is changing, right? There is no to dwell now. Okay, if you assign my property to this argument, any text entered into text will promptly be updated to my property with the text displayed. The text will update my property, and my property will update the text field naturally. Other components utilizing my property will update accordingly. There is something now cannot convert value of my property type string to expected type bind. Creating a two-way binding requires some nifty new syntax in the form of a dollar sign. This symbol signals that we are creating a two-way binding. So like why do we need that two-way binding? Let's see. So right now we are only doing one-way binding, right? That means okay, let's understand this one-way binding. Now what do I mean by when I say now one-way binding basically means the data flows in one direction from source to the view. That means and not from the view to the source. When the data so we say the data flows from the source to the view and not vice versa. Changes in the view will changes in the data triggers the changes in the view. This is what we say. When the data in the source changes, the view also changes. There is no uh, backward propagation. By what he's trying to say is, for example, if you have a user input, now this does not. Whenever the user inputs it, it does not directly update the source. There is some additional logic needed. Okay. So what I mean by this is um let's see this. So what we mean is if uh if there is an input bar, now when the user enters the text in the input, it does not um uh automatically trigger the source or update the source. That's what we are trying to say. So this is what do you mean? So for example, you see this is a view, and then here you have a state variable. I would say okay, let's let the color be this. No, let's have it. This is my state variable, right? Now this is triggering the changes, not the vice versa way. No, the changes is whenever this changes, this kind of re-renders. Okay, now let's see one more scenario wherein we have, so now we have in, so in the view we have an input fee, and then this is my source variable. So this is my source variable. um so now we need this two-way binding to take place. That means, so this way is already established, right? We don't need to worry about this. We need this one to work. So what we say, changes in view should update source. This is what our goal is to achieve. This is what we say. Now this is achieved by using something called as two-way binding. This is, so to achieve this, we use something called as a dollar sign. Okay. To achieve this binding, we use a dollar symbol. This is what he means by that. Okay, so whenever you mention a dollar, you are signifying it that there is a two-way binding that exists. The dollar sign creates a two-way binding for a view component. Just add dollar sign to my property in that argument space, and then you will have the two-way binding. Okay. No. Now let's see the concept of two-way binding in context of subviews. Subviews is a view inside a view. Mhm. And then you have a, there is another now now let's see inside subviews. Okay. Binding inside a subview. A subview is basically a view inside a view, right? So you have one view, and then inside that inside that you kind of, so that subview is basically when we are not inside the local scope of that. For example, now right now this is okay. When so is the, yeah, content view is here. Let's create another struct and then say this is sub view. Then we say confirming to view, and then the default code comes, and then we say text and say hi. And then inside this struct, I have something called as again where my okay pro this has to be a string. We are not initializing, so I'm mentioning that this is a string. Okay, now so what if inside this text I'm calling this some view, say some view, and then I'm passing this my property. So does it work here? This is my property, and instead of text I say let this be, it's coming. So I have a struct content view, and then I'm passing that to that my property, and then I have a button that changes that property's value. Okay, and we are currently, now this setup works fine. This is what we are doing, right? This is working perfectly fine. There is no issue with this. The only problem that I think is here, even there is no two-way binding, right? Where are we changing on clicking? Remember, this string is B, so whenever I click this button, it does trigger that change. So that other thing should. Right now there is no two-way thing happening, right? There is no text field over here. So what if I have a text field here, and then inside that text field, what if I make a change? That is autos text field. Okay, so it's a text field, and then I say this is content view, and then I say there is a argument for text, and then let's store my property. Okay, now this has to be a binding string, right? So you kind of do, because where is the box? I don't know. Wait. Let's see it on emulator. That would be good. There is no box coming up. I don't know. Wait. So I have my property, and then I'm setting it to this is a content view. This is right. I'm saying it, and then straight right. I've assigned this. But where is this content view? Why is that not coming? Like, where is the field? Let's see. This is button one. This is the topmost string that has come in, and then the moment I click this button, okay, so my property is now changed, and then it's changing to this is getting passed to the subview. When subview I'm having this text. Let's see this. have a text here and say this is sub this is a view, and let's put this inside a v stack. Kind of. So I'm going to yeah, this is let's do no, come outside and from here. Okay, and control X. There is okay. So this is my subview. This is the oh, why two things over here. This is the view. This one now. So yeah, so is this okay? Okay. So then right now I'm having Xcon. So this is my property. Let's get rid of this thing. For the time, let's only have the text click me or something like that. Let's say this is click me. Okay. Icon. We're not creating an instance of that struct right now. Let it be that way. This is syntax error. Where is the syntax? I don't think so. This is the issue. But yeah. No? Is it? There is some syntax error he's saying. Expected. This is closing. This is closing. This is. There's some parenthesis missing somewhere. I guess it's about this one that we. Not the navigation. Which ones are some view? This is. Okay. This is a V stack as well, right? Yeah. Yes. So now, this is. I have a text, right? I'm not using that. So I have this click me. This is the original text that is coming on the top, and then which is saying this is my string button one. Then I have my property, which is inside the view, right? So this is my string button one. I can get rid of this as well, not needed right now. And then I'm saying there is this text field isn't coming. I don't know why. So let's see the so I have text field, and then I have kind of, but where is the text field? This has to be before the view. This is my string button, but there is no. Okay, so here is the text field that has come. Okay, and then so right now, so if you see right now, the two-way binding. Whenever I change the content of this, right? For example, let's run it. Let's have the F1 thing. Here, besides this, I have to rebuild it. Let's rebuild. and build successfully. Instead of clicking there, whenever I type this, and then is this updating my, because now I've entered something, right? And then instead of click me, I should uh, oh, this is going to get this. Let's bring the console up so then we can see the console. No, how to see the console, yeah. I forgot. No, I don't want to go to the thread section. Yes. No. Just let me be on my content view for the time being. Mm, and then let's all variables. No, and does it show here? Exception. No. GPUs. No. GPR. No. Why is it not? Let's add a breakpoint here. And then let's see. Whenever I get to that point, now maybe. So now you come in and do something. And then let's go to Xcode. Have I hit that point? Uh, why isn't it coming out here? And this is no. Come here. This. Um, yeah, I'm trying to see that text field binding. Um, let's see. Okay. We need, but then obviously, yeah, that thing I'm not able to get in my UI. So when he says, okay, so what he's doing is now here, let's add something else. I say when I submit this, now just print my property. Does this change? Yes. So whenever I say and I do submit now, let's come here. I think it's changed. I don't know. But technically, it should happen here itself. Okay. So something has happened. Let's see what is. Uh, yeah, so now the value of this property has changed, right? It's saying this is my string button drawer and whatever things has come. Oh, there is thing. So now the value is, so the previously this is my string button one. Now it has changed. So this is my string buttons DDF something you're doing. And where are we? This is oh, so see what is happening is now by default it shows us this button. Now when I clear this thing out and then I say this is button 2, then why do I do enter? Now when I click this again, this is saying I'm reassigning here, right? I don't do the reassignment here. Just say print and then this. Okay, this is the label. Okay, let's now have a text saying what my property is. So I say okay. Let's let that is not needed right now. So if I refresh the view, okay, so this is string button one. Now I am deleting this and I'm saying entering a new string and then I do the on submit. And now when I click me, what has happened? Is this changing? So let's get rid of the string and then say entering a new string and do click me. Now I've come to a breakpoint. Let's proceed. So okay, how to step over it? Okay. Yeah, I'm just initializing the text over here. So let's get rid of the point. I don't need the breakpoint now. I don't need all this. Okay. Now why isn't the text changing here when I do on submit? I should have the text. The result of text initializer is not used. Now what is this? Where is this one? You can do something like print my property or something. This has to be an action, right? It doesn't be a view there. Kind of replace build and then get this thing on. This is G1 and now I do click me and then let's see what happens. Have I got anything here? Oh, let's try it again. Come here. G1 okay, do this on submit and then click me. Now I've come here and see now my variable has changed. So now the two-way binding is happening, right? The data from this text field is going to that variable. That is basically we have achieved that. Now we were trying to see in subviews. Now we haven't. We were seeing with the thing with subviews. Now we are current now this set of xy the text. So this is running fine. Now what we are doing is instead of having that thing here, let's try manipulating something. Now this is I have my sub view, and then inside the main view, uh, so instead of manipulating it in here, what if we try manipulating it inside the sub view? It's trying to say. Just instead of passing it down, what if we try to do it in the sub view directly? We'll say we'll get an error saying cannot modify my property. Am I correct? They will say cannot find that my property in scope. So then so what the way one way to is you pass down from parent to child view. Okay. So even if but when I do passing, I'm not changing the original my property. I'm changing the one that is in the local scope. So what to do? What to do? Ideally, I want both of them to change in the both views, right? So then we make use of something called as binding wrapper. Let's understand what the problem is, so that we can see. Come here. Go to tail draw. Oh no. Yeah. Binding it is some view. So then this is a view, and then I have a property called as my proper property, and then I go text and say this is main view. Okay, and then I had header to this. Let's bring this in the center. Now I have another block. Let's move this. Now this is like my child view, and then say child this is my child view, and then so this is main view, and then this is child view. So then so what if I want to change now this my property is This is local uh, to main view, and then if I want to access this in the child view, uh, in child view is by passing it through the if I pass it through the initial ini you pass it through the initializer, right? Okay, but then now if let's have this thing down. If you make changes to the one passed in the its local value will change, original not the original one, right? The local and not the original one. The original will remain. And so how to solve this problem? So the way to solve this problem is by using at the rate binding. Now at the rate binding, designed to work with two-way bindings. So now there is a limitation. So at the rate binding will work only when there is two-way binding. For example, you must have the dollar sign when the property is being passed. So it has to be a two-way binding. So in the subview, the only way to modify it is using a two-way binding. For example, in the main view, or no, in the content view, have it like a state variable that is being passed as a form of two-way binding, and then grab that in the band in the in the binding wrapper. Okay, so then if we use other rate binding, if you want the state property to retain its observable functionalities in subviews, basically what is meaning to say is using the subviews we can changes the state or the the property of the original not localized one, the original one, and then pass your state property to a subview and assign the parameter to a new part with at the rate binding, and the binding changes the dependent will update accordingly. Any changes will also propagate back to the state property. And so we want them to be observable, right? Like the changes have to be occur. There is one thing. A two-way binding is designed to work with only either rate binding is designed to work with only with two-way binding. We must use the dollar sign when passing. For example, from the main view, when I am sending it down, this is the main view. So the content view is the main. Whenever I'm passing it down to the main to the subview, always use two-way binding. It will not work if I don't mention two-way binding. Use a dollar sign. So then I say the solution. So what's the solution? We use at the rate binding. There is some problem with this at the read by. Let's see. Okay. Let's come and have a text. So the first point is this will only uh, work if the property has been passed using dollar or two-way binding. This will help us to manipulate the original value from subview. So this is how, or in other words, it will make it observable. Okay, that's all, I guess, good for this lecture. See you guys in the next one. Till that time, take care. Bye bye.